All right, so we're back, and this time we are taking a look at problem number 95. And here our instructions are to solve for x, and we've got at least two big obstacles that we need to overcome in order to solve this equation. The first is that we have three different terms with an x in it. So if our objective is to get to the place where x is equal to some number, right now we're quite far away because we have three separate x terms. The other problem that we have is that all of our x terms right now are trapped inside of logs, and so we need to get them out of those logs in order to be able to isolate them and continue doing opposite operations to solve for them. This is a case where we're going to need... Hold on just a sec. Come on, Dex. Let's go, bud. Out of here. So the first thing that we're going to have to do is we're going to need to start condensing the number of terms that we have. And we can see here that we've got the difference of two logs, but that we can restate as a quotient using the quotient property of logarithms. So we can restate this as the natural log of x plus 5 is equal to the natural log of x minus 1 divided by x plus 1. And this has actually helped us in two regards. The first is, okay, we've got one fewer term, so that's helpful. But the second is, now we've got two terms on either side of the equation, and both of them are natural logs. But the opposite operation of natural log is natural base. And so we can do the same operation to both sides to get rid of the logs. Awesome. And so we can take base e to both sides. This is helpful. Base e and the natural base cancel each other out. And so we've got x plus 5 equals x minus 1 over x plus 1. Okay, so we've solved one big problem. We've gotten rid of the logs. However, other challenges have introduced themselves. Primarily right now, we've got our variable in the denominator, which is the last place that we want it to be. Now, I do want to point out something really important here, which is that these parentheses here are still implied, meaning we can't just say, well, x divided by x is 1, and negative 1 divided by 1 is 1, negative 1, and so 1 minus 1 is 0. Like, we can't just, this does not all cancel out. Let's just use numbers to illustrate why. How about we have 4 minus 1 over 4 plus 1. That's 3/5. That does not cancel out. So we have to sort of like remember our order of operations when we're simplifying. And basically, if parentheses are present, we can't just bust into them. There's going to have to be something that we're going to do. So these two terms do not cancel each other out. However, when we've got something in the denominator that we don't want there, we can move it just by multiplying. And so we can multiply both sides by x plus 1. So here, this x plus 1 cancels out this x plus 1. And so now we've got x plus 1 times x plus 5 is equal to x minus 1. In other words, what we are now seeing that we have here is a quadratic equation. And we can solve quadratic equations using the quadratic formula or factoring or other methods that we might know. But the first thing that we're going to have to do if we're going to solve a quadratic equation is that we need to set it equal to 0. So we're going to FOIL this. We've got x squared plus 6x plus 5 equals x minus 1. And so we're going to need to subtract x and add 1 to both sides. And so we've got x squared plus 5x plus 6 equals 0. Now, if we don't like factoring or we don't remember how to factor, we can always use the quadratic formula. In this case, though, this is definitely an equation that can be factored because we can just rewrite this as x plus 2 times x plus 3 equals 0, because 2 times 2 is 6, and 2 plus 3 is 5. So we're kind of just reverse foiling. So this means here then that our solutions are -2 and -3. Well, I should say our candidate solutions are -2 and -3. This starts happening more frequently in math as the problems become more complicated. But one of the things that happens is when we have to go through a lot of convoluted steps to solve, what we end up finding at this stage here with the -2 and the -3 is we're finding candidate solutions. But we might have accidentally solved for a candidate that's not actually in the domain of the original function. Again, this can happen when we do a lot of steps like this in order to solve a fairly complicated problem. So we look back here and we look and see, oh shoot, if we plug in -2 here, we're trying to take the natural log of -3. That's no good. Negative numbers are not in the domain of logs. Same with -3. So actually we've gone through all this work to find 2 candidates, only to find that actually neither of them work. And so here we're just going to end up with sort of an NA. There are no real solutions. We can go through a process and find candidates, but in this case, when we do the final test and attempt to plug them back into the original equation, we find out that our candidates are not in the domain. And so this is an equation that looks like it should have some solutions, but in fact it has been set up in such a way that it does not. And that can happen. All right, I'm going to go ahead and clear the board, and then we'll come back and take a look at your final question, which is number 100.